Okay, let me present my screen. So first of all, we'll go through the things that we cover at a high level, and then we'll continue on our transformation and actions. So today we'll be covering the transformation and action like the complex joins and other things, right? So let's see. Okay. So I'm sharing my screen of this Spark architecture. Okay. Now guys, let me just, so in from the interview point guys also, right? The knowledge of Spark architecture is very important, right? Because when you are going to the interview, interviewer will ask you that how in-depth knowledge you have on entire Spark architecture, right? And yeah, there it's all components. Now, let me take you through once again. So what we discussed earlier, right? Yep. So whenever let's say you are running any Spark job, right? That Spark job, we just move this over here. It's yeah. Yeah, now seems better. Yeah. So guys, when you are running any Spark job, right? You pass some parameters that okay, how much amount of basically memory you need, driver memory, number of executors, right? The number of cores and what are the piece of code that you wanted to run, right? All this information you passed to your resource manager. So when you, so resource manager is a central component of your basically distributed computing, which take the input from the client. This take input from the client, okay, and manager will then create one basically driver or application master, okay, in any one of the node manager. On what basis it will create this application driver or application master or driver? Based on amount of driver memory you ask, right? So when you are asking that okay, I need a driver memory of 20 GB, it will spin up one process which we call a container, okay, any one of the node manager, because this cluster is of huge capacity, right? 1 TB memory, 200 core and 4 TB. It will find at any place, do I have the 20 GB of memory, and it will spin up that basically container. The moment let's say container got created, now container is your JVM process, right? And your code is in Spark. So what Spark developer did, they build a wrapper. That wrapper convert that Java wrapper provide the main method to your this entire execution. Okay, you don't need to get into what they have written in code, but at least to know okay, they have built some Java wrapper which will and your code is Spark or your code can be in Scala in any other language, but JVM, since I told that container is a JVM process, and to run any JVM process it need a main method. So that Java wrapper develop that build that logic to execute this piece of code with the help of uh, utility that they have built. So now container will try to run this entire things. Okay. Now container know that okay, this container I'm talking about, container or application master or driver. These are the same thing when it is running on any one of the node manager, right? Now this container when it's executing, it go through this detail. Okay, it need 4 executors, right? 10 GB of memory, 12 executor core, and this is piece of code that I need to run. So then this application master or driver again ask to resource manager, okay, I need this much of data, basically this much of compute. That is, I need 4 executors. Okay. Then resource manager told, okay, I have these 4 executors over here, which I have highlighted in another color, right? Plus it this resource manager plus this application master also asks that it need 12 cores in each executor. Okay, it give the 12 cores as well. Okay, it see okay in this executors I have 12 cores is nothing but the guys when you are doing let's say multi-threading program, right? There is a, and if let's say you wanted to write let's say 10 multiple processes parallel, right? Then you should have that much of core available, right? So that's how that's what the core is, right? And then you need, in each executor, you need a memory of 10 GB. Okay, it allocate all these things. It see, okay, these things are available. Then once resource manager tell application master, okay, these are all the processes wherein you can find this amount of configuration. Then what it do, application master, it will spin up another container process over here, right? And now this container process is executing your piece of code along with the data, right? So when you are uploading file, I told you, it will, when you are, let's say, I'm this, when need to run this piece of line, right? Spark.lead. It, and your file could be anywhere, right? It could be here, it could be here and here, right? Because data gets split in terms of partition, and you don't have control that which node or which node manager that file would file partition would go to. Okay. Now what happened? Spark basically. So the moment this line execute, right? What happened? Your Spark will read entire file in memory in the because it have now this 4 executor allocated, will load this entire file in memory, right? With the help of 40 GB of RAM it have, right? Because it have 10, 10, 10, 10, right? So 40 GB of RAM it have, and it start processing. Then it apply narrow transformation. So of course, some file might be here, but it will take entire these things into the in these 4 VMs and will start processing. Now it will apply the narrow transformation. Let's say filter by in second condition, second piece of line I have applied it. It applies some narrow transformation, and then it apply wide transformation. I explained that when it apply narrow transformation. So let's say one partition. So let's say 10 partitions, because our file is, let's say file is of how much, so the size of file I have over here. Our file size is 5 GB, right? So let's say our this file is 5 GB. Then that means, and each node, each basically this partition size is, default partition size is 128 MB. So how many partition it will create? 40 partition, right? So 10 partition would come over here and here, right? So Spark would did all these 40 partition at a one go and will start processing. On each 10 partition, let's say on this 10 partition, it will apply narrow transformation. These lines, right? On this 10 partition, it will also apply narrow transformation. Same here, same here. Now, once narrow transformation done, then it apply wide transformation. At the time of wide transformation, data from this node would go to this node would go to this node, right? So that's how these internal things happen. At the moment you call action, actually one job get created, right? And then that job get execute on your Spark cluster. Okay. While I am explaining, if any question, just you can interrupt me, guys. Okay. Now I also told you that your Spark, whatever code, it convert into series of jobs, stages, and tasks, right? The moment you take any action, in our example, we say seen, right? We call the show. The moment you call show, collect, count, these are the action, right? Spark code can contain multiple action, right? For each action, there would be one or multiple stages. Each white transformation result into the separate stage, and every stage execute in parallel, right? Depending on number of data frame itself, the data frame partition itself, right? That's another important point. And each stage can have multiple tasks based on a partition in stage. Spark will create a task for each partition. So this is how, guys, entire your code is divided into Spark job, stages, and tasks. Okay. Now, guys, we also talked about other things like, let me share that thing, the PPT. So whatever we talked about this one as well, right? Whenever you are running your code, it not just run as it is, right? Your data frame, whatever I showed you, right? Spark.read.csv, right? Your data frame, for example. First of all, it go to the multiple phases before execute it on cluster. So first of all, it create the your whatever piece of code. It's unresolved logical plan. What is the meaning of that? It just know it have very little information about table schema. Let's say CSV file, right? What is the headers in a CSV file? How much amount of data it have? It have very less information at this stage, right? Then Spark catalog come and it converted into the resolved logical plan. What this resolved logical plan do? It give that information. Okay, how much, what are all the headers in my CSV or my table have, how much amount of data that I have, right? So all this information will get into the resolved logical plan. This is the analysis phase basically. Then there is a catalyst come in picture. What is catalyst do? It create the optimized logical plan. So when you are running any piece of code, right? uh, let's say in your piece of code you have applied a where condition. I'm giving very basic example to you. Let's say you apply the where condition. uh, 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 First you do group by, okay, and then you apply where condition, right? Let's say you select star form and do group by and then apply where condition on top of the data frame, which is not good way. Best way, if you wanted to apply where condition, you first apply where condition so that you can filter your data, and on top of that you apply group by, because the moment you apply group by or join, data gets shuffled. Now imagine if you apply where condition at last, okay, you are unnecessarily shuffling huge data, right? And which will give the more cost to the cluster. So that's how this optimize logical plan do. It create one optimized plan for you. Now of course once plan get created, it need to execute, right? Then it create the multiple physical plans basically. And that physical plan, it's a cost model basically. What this cost model do? It see where I should execute on which node and other things, right? That and and which node I should execute that particular piece of logic and all these things, so that you should consume very less compute from your cluster. So main purpose of physical plan is to execute your job in a such a way so that you can use your compute in your cluster very effective way. So it select the best physical plan and then it create the RDDs, right? And this RDD get executed on a cluster. Now another thing also I talked, now when this RDD executed, right? This RDD uh, doesn't execute as it is, okay? This RDD is also further divided into basically what happened exactly in Spark execution flow. This RDD is converted by task scheduler into stages of task. I told in earlier slide, right? Not earlier slide, in draw when I was sharing, your job is split into the stages and tasks. Who did it is a task scheduler. That could be also the one of the interview question. Now, once that stages of tasks are ready, who execute it? It's your task scheduler. And and with the help of whom is a cluster manager, right? I told you, right? Because your application driver will execute it, but an application driver has a one component that is task scheduler. Okay, your it would execute, but cluster manager need to know which where I need to execute, right? In which executor does it have the enough memory? Does it have the right partitions on which I need to execute that piece of code? So all this information cluster manager have, right? So it execute this task with the help of a cluster manager, and then that piece of task, right? That is what a piece of basically piece of code and a piece of partition. On that, your worker would actually run and execute your job, and then if then it respond back to your driver process. Then it respond back to your this driver process, right? Yeah. Once entire execution got completed, it responds back to this driver process, and then this driver process can do further operation. Maybe it can load into the same cluster, or it can even move data to another location or show whatever. So this is how one thing I just wanted to reiterate to, because in when you are going to interview, people would ask. Now, one question might come to you guys. When you are running the things on, we run Spark command on a Synapse notebook. That time we not give any Spark submit or anything, because Synapse notebook, Databricks, they take care of all this complexity independently. Means they handle it that in a such way that you don't need to specify any one of the things. They know that whenever you are running piece of code, how much amount of memory it required, core it required, and all these things. But when you are running on any on-prem cluster, then that time this information is important, because your on-prem clusters are not that much of mature as compared to Databricks or Synapse, so that they can understand by just looking into the piece of code how much amount of executor and memory it requires. But that doesn't mean that you shouldn't know these things, because when you will go to the interview, they wanted to know that how much in-depth knowledge you have on Spark component and all. Otherwise, people generally just run data queries on a database or Synapse, but since they don't know the problem come when they are executing, when they are running the query on huge data, right? To, let's say I have 5 GB of one file and 5 GB of one file, and people if directly execute those things without having proper knowledge, then of course your job get, let's say, skewed, and you will not get the better performance. Your pipeline take more time. So that's why this knowledge is important, guys. Now, on top of that, one more thing I just wanted to cover, guys. See, I not covered this part earlier intentionally because this architecture is quite complex, right? And you might need to spend time to go through it. Now, in this architecture, there is one more component. Okay, let me talk to that one as well. So see, till now we are with the YAN, right? YAN, Spark architecture and YAN. What that tell is distributed computing. But guys, I told you this cluster I have, right? This cluster contain cluster I built of, let's say, in cluster in my cluster, each VM is of 10 GB RAM, 20 cores, and 400 GB storage. Now, once this cluster is ready, and whenever I am uploading file, I told that file gets split into the partitions, right? It can come anywhere. But who do this job? That is not a job of the, when you are uploading file, right? You have not run any program now. You are just uploading file to your cluster with the help of some command, and Spark not yet come in picture. So who do that partitions and all? Then guys, answer is your HDFS architecture. Now I will just talk about. Okay. So what happened, guys, when you are running any piece of code, right? Uh, the YAN and HDFS, they work in together, right? So your HDFS, it's basically distributed data storage, and the YAN is your distributed data processing. Now in HDFS, you have the name node and passive name node. So what happened, guys, whenever you are running one piece of, whenever you are uploading any file, that file uploaded by your name node in your HDFS architecture. So what name node knows, what are all the data nodes I have, right? So if I talk about here, this name node knows what are all the data. Let's not go to here. So name node knows what are all the data node. Data node is nothing but the basically VMs, right? And the storage. What are all the storages I have? Now this name node then split your file into 128 MB partition and upload it as a data block in any one of the execute VM where the file basically storage is available. That is the job of name node. If any one of the worker, and these nodes are nothing but the worker in your earlier architecture, I showed you this is a master and these are all the worker nodes. So in here, these are all the worker node only. So name node in ADFS knows, okay, what are all the worker that I have, how much amount of data each worker, basically storage each worker have. So whenever you are uploading any file, that file gets split into this data block of 128 MB, right? And once that file gets split into 128 MB, then your YAN architecture come in place. So just wanted to guide guys this give another thing as well. Basically, because HDFS is also one of the critical component when it's come to the when you are setting the thing setting up the things on prem, right? And even whenever you are running your piece of code on a Databricks, or Synapse, that time also it is there, but Spark, but Databricks and Synapse handle that complexity internally with the help of, in case of Databricks, it's a database file system, right? On-prem you have HDFS, right? HDFS file system, and on Azure, basically Synapse, you have Azure Blob Storage, ABFS file system, right? That's what they call. So these file system take care of your entire data, right? And it have the same architecture, name node, data node, right? And whenever you are uploading any file, that file gets split into the piece of data block of 128 MB. Now this partition size is configurable. You can configure it to any size as per your requirement, right? And then another thing, right? Just wanted to talk, in name node you have, let's say active name node, passive node. These are just maybe guys to, let's say my this name node get, let's say, damage, right? Then I should have something in ready state. So that's what the passive name node is there. How it active in, so I am saying that it would get activated if my name node get down. How it do? With the help of shared log, because name node knows all the component that I have in my worker node, all the data node, right? And how much amount of storage it have, and it share that all the logs to the passive name node. The moment, let's say, and these are talking with each other, right? The moment, let's say, passive node not get any information from the active node, right? It's not get any bits or anything. Okay, it's checking, okay, are you alive? Are you alive? If it's not responding, then it act as a then name node, and then this would come as a passive node. So that's how this internal architecture happen, guys. Yeah. And one more thing, guys, whenever you are uploading any partition, that partition doesn't just go into the any one of the worker node. That partition also get replicate to another node, so that you should have high availability. Let's say my one of the worker goes down. So if I talk about this architecture, whenever you are uploading any file, that file can be here. Let's say that 5 GB of file can be here and here, right? But what if one of the node goes down? Your file would get lost, right? But it doesn't happen this way. It would load one file over here, but the replica also it create over here, so that in case this node goes down, you still should have that file available. And that's what we call the replication. That replication is configurable. You can configure to it having replicate to 3 VM or 1 VM or 2 VM. So that one file in that way, let's say you set up the replication as at a 2, it will create one file over here and one file over here. If you create the 3, and then one here and 2 here. That's how it maintain high availability, guys. So this is how, guys, entire things happen internally. It's a combination of HDFS plus YARN. Whenever you are running even in Databricks, right? All the things are there, but it's they are, you are just working on abstract layer. You don't know most of the time. You not need to know that what happening internally from the coding perspective. But when you're going to interview, right? And it may be possible that interviewer would go to the in-depth knowledge of these things. So you should have this knowledge. Okay. Any question, guys? Something not clear on YARN HDFS?
We are good.
Okay. Thanks. So now let now go to the our, now we will continue on our entire this data frame processing. Now let me share my ID. So when it's come to the interview, guys, right? There are two, as a part of data engineering, the important thing that you need to aware of first is you should have good knowledge on this Spark component, and of course your data frame activity. That what sort of you, because in day to day you would be working on data frames. Okay. Now, guys, just give me a second. Okay, so I have an idea. Okay. Now, guys, let me. So in yesterday's, sorry, in last week we talked about row, basically column level operation, then row level operation. Today we will go to some other topic, that is join and other stuffs. Okay. Okay. Now guys, see here I have just have to show you the file on which will be applying this transformation. See, I have an employee CSV wherein I have the employee first name, last name, and department salary, join date and location. Right? It's a employee data. Then I have project CSV. What is the unique between employee CSV and project CSV is the employee ID. Okay. Here also I have employee ID. Here also I have employee ID. Now this project CSV have information about the in which project this employee is enrolled. Okay, that is project name, for example, data lake migration, HR automation, finance, app modernization, all these things, right? In which project that particular employee has been enrolled, manager name, team size, okay, performance score, score of individual, right? And remote eligible. Let's say if this employee is eligible to work remotely and all, right? So this is how data is available in this employee data set and project CSV. Now, guys, let first of all we import few things, and so guys, see, uh, of course, if I just remove these things, it would show error because it needs a Spark session. So that's why I import a Spark session from spark.sql, right? And anyway, when I will be using some functions, right? I know that I need this all the functions accessibility in my code. So that's why I import star over here from Spark SQL functions. I need all the functions, let's say aggregate, sum, and other things, right? Now, whenever you are running any piece of code, you need a Spark session, right? And how you can get that Spark session with the help of Spark session? You import Spark session, that builder app name is just a name. You can give any name over here. It just to know that what is the name of that application. You can give in your name as well, not issue. It can be any name. And then get or create. What is the meaning of get or create? If you are already running your Spark session, then it will get that one, right? But if it is not available, then it would create. So it's if already available, give me that Spark session. If not, then create it. So in entire execution, you could have only one Spark session, right? That's why. Now, guys, let's read these files. Okay. So let's say I wanted to read the files in terms of CSV. Okay. And then let me give the file location. C data. CSV. Then in my case, header just I wanted to put as a true. Okay. And it just prompt everything. And info schema is a true. So what's the meaning of this, guys? I need because in my employee CSV I have this header available. I want okay it to be treat as a header. Okay, true. And then info schema is equal to true. Same I will do for this one as well. But this is project CSV. So here I will just employees underscore DF. This is data frame for employee DF, right? And this is data frame for So these are all data frame I have created. Let me just show. And now guys, today we'll apply some series of joins and other things. So let me first run this just to see. Okay. Okay, fine. Yeah, I think we could be able to read data, and it in the for first one, it show that okay, it read the 5 employee record, right, and show it, and the project record also it load and show. Now, guys, let see the couple of joins. Okay, so we'll talk about this first of all inner join, then our other join, right? So let's say first thing, if let's first talk about inner join. Okay, so what is the purpose of inner join, guys? It's match the record in both employee and department with the, based on your unique key. Let's say employee ID. Let's say your unique key, right? So how to do that? Some of things might be, guys. Of course, you should be familiar with this, but let gradually increase the complexity. Rather, me directly go to the let's say Windows operation and other things. Let first we'll do simple things, right? Join project employee ID. Okay, okay, fine. How? See, employee data frame, join project data frame, right? On what? Employee ID. In both things, I have the employee ID as a unique key, right? And this name should be in the same way, employee ID. And how I wanted to join with the help of inner join. Okay. Let me show you. Okay, instead of let me doing, I can even do this thing, but sometime what happen if my data frame have let's say more data, show df dot count. So one of the thing guys, right? When you are let's say joining, right, or doing any operation and you wanted to see entire data frame, by default it show either in earlier case I just give the 5 row to show. That's why it show 5 row. Otherwise by default it show the 20 rows. But if you do this way, it would show all the rows that is available in your data frame. What happened? Okay, see, sometime we go with this auto pop-up and that make thing wrong for us. It was employee ID and not basically ID give some auto suggestion, right? So that's how something things get wrong. So always make sure that whatever you are writing code, it should be because it's a case sensitive. Even if let's say you make any mistake over here, it would show error to you. And I think I not give this thing. That's why it's come. So earlier issue was I just give the count, but count is a function, not something else. So that's why earlier I just give these things. But when I apply this function things over here, then it show, right? So now here we got all the records which are matching between project data frame and employee data frame based on your employee ID, right? So this is how the inner join would work, guys. Now let me just comment this, okay, and let me show you other join as well. So the join and all, see, very basic. So what I will do, instead of running each and every time, I will just do multiple joins. Okay. Now let's talk about another join, that is, let's say left join. Okay. So what is left join, guys? All the record from the employee. Okay. Let's say on my data frame, when I am applying left join, I kept my employee data frame on the left side. Then what happened? All the record from the employee and match one from the department would come. So let me show you practically how this employee data frame join project data frame on employee ID. Okay. And how left. So basically what happened in this case, all the, though let's say in employee data frame there is no matching record, right? But still with respect to right side, but still it would come, right? And other would come as a null. Let's say it doesn't find any matching between employee and project. Let's say there is no matching in employee CSV. Let's say for example 140, right? And here I have, for example, 140, right? 140 is a row for which there is no matching in a project, right? There is no matching. I have just matching till 120, right? Till 120, and it anyway not have that thing. So let's see how it respond, guys. Sure. This left join. Okay, it show now, guys. See, employees. If you go to the employee CSV from for 120, right? In my employee CSV, there is, for example, all these things 119, 120, all these things are available in my employee CSV. But for this, you see, nulls are coming. Why? Because in my project CSV, I don't have anything like those record. So if there is no matching found, it would give the null matching found on a project side. It will give for those record as a null. And if it found any match, then it would give the right value. Let's say 101, right? The 101, I have the data over here, right? And I have the data over here as well. So that's why you got entire record populated. No nulls over here, right? But let's say this case, 120. Here I have record available over here in my left data frame, right? Left join. But there is no matching at a project side. So that's why whatever available in my employee data frame that come, but whatever not available, that entire thing come as a null, right? So this is how, guys, we sometimes when we want all the data from the left side to be there, do it match or not match, right? Then in that case, you would use left join. Now right join, same, just you apply things over here, and it would show all the data from the basically right side, right? So it would return you all data from the right side, though if it is match, well and good. But if not match, then it would still return. But yes, for those column which got not match, for those you will see the null as a value. Okay, so you see that in case of a right join, okay, on the right side, I have project data frame, right? So all the data from project got written, right? But these cases you can see, right? 130 and 131. Since they don't have any matching things over here, that's why they got null in this case. Whereas in project data frame, the 114, it have the matching over here, right? 114. And that's why you got entire row populated over here. But if there is no match on a SO, what right join indicate, it's written all the data from the right side. If it is match, then good, it would return entire data. But if it not match, it will still return. But for the non-matching columns, sorry, non-matching row, it would give value as a nulls for those respective columns, right? Now, guys, there are, okay, one more we will talk, that is outer join. Okay, what it do? Let me, for outer join, let me just take outer df. Okay, and outer df dot show outer df dot count. Okay, because I am showing outer, what outer join do? It it combine, it return data from both, right, left and right side. Basically it combine all the record from both data set and fill nulls where no match. So let's see. So these are the basically common join, inner join, left join, right join, and outer join that you will be using in your day-to-day activity. So I think let's start with this basic one, and then we'll cover other things as well. So you see, all the things which got match, I got a proper result for that, right? See, let's say 101, right? Entire row columns are populated and other things, right? But if there is no match, let's say column number 115, right? There is no match on this side, then it would come as a null. So basically it would, what outer join do for you, it also called the full outer join. Okay, it combine all the record from both data set and fill null where no match. So for example, let's say this 115, right? This 115, see, this 115 is available in employee here, but not available over here. So that's why for 115, I got employee records, whatever the basic columns available from the employee. But since I don't have any record available for this 115 in project, for those uh, row, I got null as a value. So it return entire thing to you. For non-matching thing, it return null. That's what to simply. Now let's talk. There's another uh, join which is let's say it's called left anti-join. Okay, it return the employee. So if I want, let's say, return the employee not found in department. So I have this, I think, right? I want the employees which not found in department. Sorry, not department, basically project. Okay. Dep I might say the department and project is the same thing, right? Just take at the same thing for this at least, I think. So I wanted to get all the employee not found in, let's say, project. So how I should do? For that, you apply the same thing, but it's a left anti-join. So what I'm doing, I join employee with the project. Okay, on what basis? Employee ID, and I want left anti. So basically, in left anti join, what I'm doing, I need all the, yeah, I need to return the employees not found in departments. So let's run it. So when guys you will be going to interview, of course, there might be chance that interviewer may ask you to share a screen and write a piece of data frame. So you should be well versed with these joins and all. Okay. What I'm trying to do over here, left anti-join, return all the employee not found in department, right? So see department or project whatever, right? I don't have entry for 115 116 in my project. I have till only 114. So that's why since 115 to 140 all come here because we apply this left anti-join. You should know these things, right? When to apply left anti-join. If something that you need all the records which are available only in specific part of files, right? Then you can apply left anti-join in that case. Okay. Now guys, let do some conditional joining. Okay. These are the basic join that we generally use. Okay. Uh, Inner join. Just to recap, inner join you will use when you want to join based on particular key. Left join when you need a data, all data from the left side to be written. If there is no match, then return those as a null. What is and then join. You in join you will get all the data from the right side if it is match, right? But if it is not match, that would also get written, but as a null, right? If let's say some rows not matches from the right side, those also get written, but the values for those respective column you will get as a null, right? And then we have the outer join. It return data from the both left and right, and if there is no match for that, let's say particular record is not available in the left side or right side, that would also return, but it would return as a null for those column for which you don't found any match. And then you have let's say left anti return the let's say you wanted to return only piece of, let's say you just want to return some record which are not found in other data set, right? In that cases you can use your left anti join. Now guys, let apply some conditional joining. Okay, we will join based on what we will do, we will join based on our employee ID only, right? But then we will apply some condition on top of that. Conditional join. Employee df dot join project df on what? Employee ID. Now I don't want how over here. Okay, what I want? I want to apply. Okay, I want to join based on this unique ID. Then I want to apply filter. Okay, employee ID will join on project data frame based on employee ID, right? Filter on what I want to apply filter. The filter I want to apply on, let's say column. The name of the column, let's say performance score. So call is stand for column, guys. Okay, performance score greater than I will use, let's say I have 4, 3. I need all the data having greater than 4, let's say. Okay, dot show. So here guys, I am applying the conditional join. In conditional join, what I'm doing, I'm joining employee data frame with the help of project data frame. Based on what I am joining employee ID, then on that data I am applying filter condition, and on a filter condition I give one column. That particular, let's say, performance score is greater than 4, then only show those records. Now let's run it. Okay, what happened? Again, that are auto suggestions. Okay, sorry about that. So basically, I use employees ID. That's why it's, and there is no column employees ID. That's why it failed. Guys, I would also encourage you to create a GitHub account. Okay, and and do your transformation and action, do this practice and commit your code on GitHub, so that when you add those things in your resume, that make things maybe better for from the other interviewer perspective, right? Okay, you are doing this hands-on operation and committing the code on GitHub and all, right? So see, now I got the performance score only if greater than 4. That's how I see in the performance score, right? So that's what called the conditional join, right? I apply join, but on top of that, I also apply some condition. Okay. Now, guys, let's join and do selects, right? So let's say that when I'm running this code, I get all the data. But let's say I just need just piece of data, right? So what I will do, again, employee data frame dot join project data frame based on employee ID, right? And dot select. What column I wanted to get? I want to get, let's say, first name, then last name, and I also need, let's say, manager name. Okay, yeah. Let's say I just need this 3 data and let me do show. So what I'm doing, guys, it's called join and select specific record from those join. Let me run it. The data frame and all, it's almost equal to SQL, right? If you know the basic SQL thing, they are almost same, right? So you see, I just apply the join between project data frame and employee data frame on employee ID and just took the respective column from here, first name, last name, and manager name, right? So that's how, that's what we call join and specific, just get the specific column from there. Now guys, let's do some order by, right? Let's say I wanted to sort, join and sort based on, let's say, performance score, for example, right? So how I should do? Okay. So of course, I will keep this query as it is, right? Employee data frame dot query data frame on employee ID I wanted to join. Now, guys, I want to apply order by clause, right? You see the moment you to click over here, it show all the this operation that you can perform over here, right? Order by on what I want to apply order by? I want to apply order by on column performance. Column performance score. Okay. Right now on a performance score, what I need? Uh, okay, for a performance score. Okay, I want to apply order by. So let's do maybe this as a second descending order. Dot. No. So I apply order by. So first of all, I join this data frame based on this ID, then apply order by on this particular column. I want order to be in descending. That's why I use DSC. You can use ascending order as well, right? And then show. Show is basically action, guys. So if I talk about the transformation action that I explain you, right? Join. Okay, we'll cover that. So you see, I got performance score in descending order, right? Starting from 4.6 to in descending order. Now, guys, I was saying that, right? Here in your Spark code, you see this is your transformation, right? You are applying join, right? Join is your transformation. Order is also transformation. Descending, this is also transformation, and the show is an action. So basically, this is how, and for each action, I told you each action one job get created, right? And and let's say whenever you're applying transformation one after another, right? Spark created DAG structure out of it, and then that DAG execute by DAG scheduler, which convert your stages of your entire, which convert your DAG into stages of task, and finally it run on Spark cluster. So that's how things internally happen. But from the front end perspective, from the this end, right, front end perspective, you don't need to, you don't know that what are all the things happening there, but actually that's how the Spark work internally. Okay, fine. Now let me go to, let's say, okay, fine. Now guys, we see some joins operation. Now let's do some other things. Now we'll do some group by operation as well, right? So in when you are in Spark, of course, in SQL, the group by and other things are the common thing, right? So let's say you wanted to group department by, let's say, salary. So what is the requirement? The requirement is to show average salary for each department. Okay. Okay. So I wanted to see average salary for each department. How to do that, guys? Now let's say I wanted to use that on employee data frame. So I have employee data frame, right? In employee data frame, I have this salary. Okay. And I have employee data frame department, data frame. I have this salary, right? And I have multiple department over here, right? You see IT, then finance, then HR. I wanted to get average salary for each department. So how to do that? Employee data frame. Okay. Then I want to apply group by, right? So group by, on what I want to apply group by? I want to apply group by on, sorry, group by on department. Okay. Now, so see, once you group data, on that group data only you apply some aggregation logic, right? So that's why you apply, you use this aggregate method. Okay. Now, on what you wanted to apply aggregate method? Okay, and what basically aggregation function you wanted to use? I want to use aggregation function as a average. Okay, in average also I want the salary basically to be aggregated. You see, it's a salary only, right? Yeah, yeah. So I group data based on department, and on top of that I apply aggregation function. Aggregation can be anything. It can be mean, max, average, right? But on which column? The salary column. I wanted to see average salary for each department. And then I just wanted to show that first. And I have also one more thing to cover here itself. So let first get to see these things. Right. So I got average, right? The H for HR average salary is this one. HR department for finance, we have the average salary as this one for marketing and for IT. Now guys, you see this AVJ salary come. What if I wanted to give some better name over here? How to do that, right? We don't want this AVJ salary now, right? We need some better naming. So how to do that? So for that, we have some alias, right? What is the purpose of alias? It can, you can give, it's a column labeling. If you want to, let's say, label column in some another way, right? So for that purpose, so we use alias. Alias average salary. Now let me run it, and we should see proper name out there rather than AVJ salary, because let's say on this data frame I wanted to apply some another transformation. Sorry, I think I not apply. So anyway, let it run so that you would understand first. Okay, you see, I apply earlier. I not, when I run this code, I don't add any show method, right? And unless until you do show or collect or count, nothing, your action won't get triggered. So you not got any output. So to get output, you need to apply some action. Still now, just you apply transformation, and that's why no output come up, because no job get triggered. So the moment you do show or count, the job would get triggered, and that, let's say you are doing, let's say, count, then you can take that as a variable or return that and print that. So that's all right. Show or count or collect, whatever. So now it should show us that group by department and get the average salary with proper name as a average salary. You see, now I got better name over here. Earlier it was like AVJ salary. So what's this alias, guys? Maybe you guys might be some comfortable with SQL, right? When I do select star from employees A, right? Comma, project B, where A dot empid equal to B dot empid. Right. So these things, guys, right? A, B, right? These are the alias only. So you can use alias in this way as well, or let's say you got some, whenever let's say you are doing the same thing in a SQL with the help of group by, right, in SQL, that time also you will see the same thing. And if you wanted to give alias over there, then that also option that you have in normal SQL as well. So alias is just nothing but labeling the things. Okay, now fine. Now let's say another group by operation we will do, group by location and count employee. Let's say count how many employee are in each location. Okay, so in employee there are multiple locations, right? New York, Chicago, San Francisco, another thing, right? I want how many employees in each location. So let's do thing, group by location. Okay, so let's do that. Employee department, employee data frame, right? I want to apply basically group by on a location, right? Group by which column? The location column. Okay, so data would get group based on a location, right? And there as well, what I want, basically I want the count of that, right? So let's say once I apply this location, I just want a normal count dot show it. Let's run group by location count. We will be covering some advanced things as well, guys. But if I directly go to the Windows operation and other thing, and maybe if I say, let's say when I will be running the things on in upcoming section, maybe data breaks, right? That time maybe I can take you directly through the code base. Of course, I will be explaining each and every line. But that time, if you go through these things, since we are going through this thing, it will not be a surprise for you. But this that code is right. So that's why this now these nitty-gritties are important. Everything, and so that when I explain other things in upcoming complex session, be it Databricks or a glue, whatever, right? That time things should be simple for you when I'm explaining any code. So location, for each location, I got the count, right? For from this data. So from let's say places we I have San Francisco location at a 5 places, so right? So that's why it got to 5, Chicago at a 5 places, and Z as a 1. So this is how guys you apply group by and then count operation to get the basically group the location and take the count from each location. Now, guys, another, let's say I wanted to group, basically another add one more thing. Let's say now to join. Till now, you see, we just apply the things based on group only, and we apply group on only employee data frame. Let's say I want to join and plus group by. So what I want to do now, after joining, I wanted to sum up the team size for each manager. Okay, so my task is I want to join employee with the project data frame. Okay, and after joining based on employee ID, I want to sum up team size for each manager. So let's see how we can do that. Okay, nice. Join and team size for each manager. So employee data frame dot join project data frame, right? On employee IDs. Okay, so employee ID only. Yeah. Okay, I don't want to how, because here now I want to apply some other logic. Okay, okay, now let's say I join guys this, but I wanted to, after joining I want to apply group by on a manager. Okay, because I need team size for each manager, right? And maybe when I'm and I have manager data over here, right? And that manager, one employee can have multiple. Sorry, one manager can have multiple subordinate associate to him, right? So that's why there will be multiple manager over here, right? And their subordinate could be the different one. But no, sorry, there could be, let's say, one manager over here, and he can have multiple subordinate, right? So that's why I wanted to apply group by on a manager name. Group by. What this will give me, guys, I join two data frame, and then I'm applying group by on a manager name, right? So that so I can group that manager data. There can be multiple manager names over here, right? And there might be some. So let's say, let me see. So it could be anything, right? Let's say John Miller is over here, right? For example, and for just these things, it could be here as well, right? Here as well. So this manager, and for this manager also, for this uh, John Miller, there are two employees, right? 101, 102. They are reporting to him, right? So that's why we are doing group by on a manager name. Now group by manager name, and on top of that, what I want to do, aggregate sum of team size, right? Aggregate sum of team size dot, okay, sum of team size dot show. So what we are doing over here, guys, I group basically, first of all, I join employee with the project data frame on the employee ID. Then I'm grouping based on a manager name. Okay. And then on that group data, then I'm applying aggregation, that is sum. Okay. Sum, right? And the team, then team size, on the team size, I'm applying that aggregation. And let me click on the run. So when you are applying group by, of course, it's not necessary to apply group by on only one data frame. You can combine, basically purpose to show this, you can join two different data frame, and then on that join data also you can apply some group by. Okay. So you see the team size you are getting right over here. So for particular manager, how much is team size? So that's how we can group that data based on a manager name and take the sum of team size. So that's one thing just wanted to show you guys. Another thing, guys, let's do join and group by project name. Okay. So what we'll be doing over here, we'll be joining employee data frame with the project one, group by project name, and on that project name, we will apply some aggregation. Let's say on each project, what is the average performance score? Okay. Group by, so it would be same as it is over here, right? I will just apply group by on a project name. So I have multiple project name, like, right? Data lake migration, HR automation, and other thing. I'll be applying group by on a project name. On this group data, what I wanted to do, guys, on this group data, now I want to uh, basically apply some aggregation, right? Let me click dot aggregation. What aggregation logic I wanted to apply? I want to apply, let's say, average performance score. Average of performance score. Join plus we are doing now group by project name, right? And then on top of that, aggregation logic I am applying. We need average performance score on that group data. Okay. So let's run this, guys. So these are the common example, guys, when you are joining and then applying the so so of course on one data frame you can apply joins and all, but let's say you have two or three data frame. You can combine these two and three data frame based on some unique key, and then on top of that combined data, you can apply your group by on specific column. Once you group data, then you can also, of course, why you are doing group? Because you wanted to apply some aggregation logic. You wanted to find mean, max, average, right? Some those things. So this is how, guys, you will get now project name, and then for each project name, what is the average performance score, right? So this is how, guys, you can write this sort of query. Now let's do other thing. Let's say I wanted to group by department. So I wanted to see highest salary in each department. Okay. So how to do that, right? So let me just remove this thing. Or we call project. Okay. So I need highest salary in each project. So how to do this, guys? So basically on employee data frame, I will I have the column, right? In employee DF, I have the one column that is department, right? That is IT, HR, finance. So let's see. Let me dot group by department. Okay, I group data. Now what I want to do, I want to do post grouping. I want to apply some aggregation logic. Dot aggregation logic on which, okay, I want to apply some aggregation logic, but what exactly I wanted to basically which what aggregation I want to apply, mean, max, right? In this case I wanted to see the max salary, right? So max of column it showed you, right? And then in a PDF I have the salary, right? So this way I can get highest salary, right, for each department. Let me run it. So you see, for HR, this is the highest salary, right? For HR department. So if I just go over here and just see the HR. So I have 68,000, 69,000, then 66, 64, and 73, right? So 73 is the highest one I got. So this is how I can get for each department what is the maximum salary. And guys, max salary, yeah, I told you earlier as well, right? If I just wanted to name it in better way, I just need to give alias and give some better name over here, max salary, and it should show max salary over here rather than this name. So just update, guys. This is how you should do this. Okay. Now fine. Now other thing, let's say what I want to do now, I want to apply join, okay, between two data frame and remote eligible count by locations. Okay. So join and count how many employees, sorry, join and count how many remote eligible in each location. So I have multiple locations, right, in my CSV. And in each locations, I want to see how many are remote eligible, right? So how to do this thing, guys? Okay. Let's write things for that. So you see here, this is employee. Okay. This is project. And in employee there are, guys, let's say location is different, right? New York and San Francisco, Chicago, another thing, right? I'm joining this data frame, this employee with project. Okay. And based on location, I wanted to see, let's say for this location, New York. Okay. How many remote eligible employees are? Okay. So let's write things for that. Now pay attention. Okay. Dot join project data frame on employee ID. Okay. Okay, first of all, I join based on employee ID. Now what next? On top of that, I want to do now group by location, right? Because I want, okay, let me, so what we wanted to achieve over here, join and count how many employees are remote eligible in each location, right? So that's what our purpose. So now, fine, we are doing group by location, right? And now on group data, what I wanted to do, group by location. Okay. Now after grouping based on location, I want to apply aggregation, right? Aggregation. I need how many remote eligible, right? Currently, so I will for that I will apply some I need basically count of remote eligible, right? So I will use, let's say, sum. Okay. Some, guys, I will use, let's say, let remove this sum. When, so when is also conditional things that in Spark. Okay. Function basically when column. Okay. When column remote eligible equal to S. okay, equal to S, then I will use that as a 1. Okay. Now let me this into the another, okay, aggregate. Then yeah, I group by the location and I am applying aggregate function sum. Then I am applying on aggregate on what I wanted to apply aggregate on a sum function, right? The sum when column remote eligible equal to S, then value is 1. Okay. Otherwise, right? Otherwise, okay, 0. And let give this alias remote count dot show. So let's see how it run, guys. So this is how, guys, things would get more and more complex when you deal with data, right? You do the join group by, right? And on a group data, you then apply, let's say in this case, I wanted to see how many remote eligible in each location, right? So that's why I apply group by, but some, right? So let's say in this case, right, on a San Francisco, I see 2 remote eligible count. The Chicago, I have 2, and New York 3, and Boston 2. In my case, there is no other anyone who have, let's say, uh, who don't have the remote location. That's why you got the 0, because we are grouping by location, and then on top of that, we are applying this logic, the remote count, yes or not. Okay. I hope this clear, guys. No question here, right? This would be a bit complex.
Yes.
Yeah. Now, group by join here. Let's say I wanted to just, let's say, join employee data frame with basically your project data frame. Okay. Or not, let's say, in employee data frame, it's employee data frame itself. I wanted to do group by join date. Okay. So let's do for that. So task for us is extract year from the join date and count the employee per year, right? So let's do that now. So employee data frame df, right? What I want to do, with column join year. So what is the purpose of with column, guys? It will add another column on top of your current data frame, right? So with column join year, then here you will apply, let's say, some year function. So year is a function, right? On what you are applying the year function? The join date column that I have. Okay. Now on this join date, what I want to do guys, I am grouped by join here. Okay. Group by join here dot count dot show. So what I'm doing things over here guys, in so basically group by join year, right? So on which year that particular candidate join, and I wanted to get the count of, let's say, in specific year how many employee got joined, and then on a specific year how many employee got joined, right? So for that, what I'm doing on an employee data frame, I'm doing with column, I'm adding another column as a join year, right? And then I'm applying year function, and on year function, then I apply on which column I am applying that year function on a join date. Okay, on a join date, then I group that data. Okay, sorry guys, what happened? Okay, yeah. On a join year, guys, then sorry, on a I apply year function on a join date, then I group that data, right? Group by join year, and then count and show. So let's see. So you see, on 2018, I got 3 join, right? 23, I got to 2, 22, I got these things, right? So how you can group basically, so in current data frame, I add another with column, right? Join year. So this is how the join year I got, right? And on that, so then I apply year function on current data frame. So current data frame join date column. In employee data frame, I have join date column, right? Wherein I have multiple join date 19 to 20, 21, right? On that, I apply year function, right? And that year, then I group by that, I group that year data, right? And then on a group, let's say once I group, let's say on a year, then I get, okay, group of 20, 2022, group of 2023, right? And on that group data, finally I apply count function to get the count of how many people join on each year, right? So this is how guys you should do group and combination of basically group and joining the year, for example. Now another thing guys, let's say I want that group by department and show the mean, max, average, all these things, right? Salary and all. So how I should do, right? I want for employee data frame, I want to see all the stats on employee data frame. Let's say minimum salary, how much is maximum, how much is right, average, and all these things. So generally, when you are doing data engineering things, this is a common thing that you would see. So mean, max, average per department or projects. Sorry, yeah, department. So let's me click on employee data frame, right? What I want, guys, I want group by department, group by on which column I want to do group by department. So I have the department. Now on this group data, I want to apply aggregation logic. What aggregation I want to do? I want to see minimum salary, maximum salary, and average salary. So minimum, maximum, average. So I group based on department. I have multiple department over here, right? And I just wanted to see minimum, maximum, and average salary for each one. So you can apply multiple aggregation in a same group data. So that's also possible. Yeah. For each department, HR, I have 4 departments, right? HR, finance, marketing, and IT. For each department, what is the minimum salary? What is the maximum salary? Right? And what is the average of that? This is how, in a single operation, we can get all this data record. So if you see what need to notice over here, once you apply group by, right? Group by an aggregation function you apply, right? Of course, you can apply aggregation function only on a group data. And then it's your choice. Do you want it to do group on a one column or multiple? Sorry, you wanted to apply only one function or multiple function. That's completely up to you how you wanted to do that, right? Now, guys, let's see some other thing. So I want to see count how many employees assigned in each project. Okay. So I have employee data frame in each project. Okay. So what I will do now, guys, I will join to get that. What I will do, I will join employee data frame with project data frame. Join project data frame on employee ID. Okay. Okay. Once I join, once I join, then I want to see how many employees assigned to each project, right? So for that, I want to first of all do the group by on project name, right? Group by project name. I think project name is available over here, right? So that's why, guys, I join employee and project so that then I can take this project name. So I join data, then I had to group by project name, right? And finally, I will simply use count. Sure. Let's run. Okay. So you see, for in my case, the only app modernization is a project wherein I have 2 employee assigned. Apart from that, everywhere you see only one employee is assigned. So if I just go to here, app moderation at a 114 line number, and then it's also available at a 104. So that's how you can get right how many employee assigned in each project, right? The count of basically in this case for app moderation it's a 2, for all others it's just a 1, right? Now guys, let we can see, I will also quickly show some other operations, okay, before concluding today's session. So employee data frame. Dot. So let's say I want to, this is a common thing, right? You need a distinct data, right? So select. So you can apply, see, on employee data frame, you can also apply select clause, okay? I think, yeah, in first sessions, I have covered that. You can select specific column from your employee data frame and do the operation on top of that, right? So you apply select what you need, department you need, right? And the department also you need in a distinct way. You just wanted to see department distinct, not show. From employee data frame, right? You have HR, finance, marketing, right? If you just wanted to see the distinct data, okay? So this is how, guys, I only have the 4 department. That's why you got only 4 distinct row. And guys, now if you see, the moment you, let's say, click over here, there are other some functions, right? Drop duplicates, right? If let's say you have some duplicates in your data, you can drop, okay? Okay, and get some unique data frame out of it. So currently in my case, I don't have any duplicates and all, but if it is duplicate, you can drop it and then you can do that. You can do further operation on top of that, right? So this is how, right, you can drop duplicate. Then let's say, uh, these are typical we call data cleansing activity, right? See, drop NA. So what is this drop NA, guys? Let's say there are some column, right? So there are some rows for which there are no value in those column, right? Let's say there are some rows, there are for those rows, there is no value. Let's say you don't have employee ID itself. Data is, let's say that is bad data, right? You have employee ID is there, but salary is not there. So sometime taking that data and getting insight out of it, it's something not recommended. Okay. So what's recommended is, a recommended thing is, if you are having some bad data, right? Some rows, there are rows, but that column value is not available. So in that cases, what you want to do, you wanted to drop all this NA or null value so that you can get this clean data frame, right? And then on that clean data frame, you can do your operations and all. So this is common practice, guys, people follow, right? So yeah. Now, guys, okay, I want to talk on aggregation as well. Other, there are some aggregation operation as well that need to cover. So maybe let we can proceed now itself so that we can then other maybe session we can discuss further thing. I also wanted to cover Windows operation as well and other things. Guys, do you want to cover now or how you want to? Any question you have before I move? Most. Okay, fine. Then let maybe I will cover 1 or 2 some more aggregation operation and then we can conclude today's session. So now, guys, let's say I wanted to count total employees, right? For example, how many total employee I have, right? So it's a very simple thing. How should you do employee DF, right? So you want a total employee data frame, right? So employee data frame dot aggregate. You want to apply aggregation. Now on aggregated, oh, what you want to do, right? You want count of star, count of star. Generally we do, right, select count of star from table, right? So how you should do the same in here, right? So you do employee data frame, then you apply aggregation logic, right? Aggregation method, count of star, right? Then you will be applying, let's say, maybe let's say you want to apply alias over here, count dot show. Currently, guys, we are just running this line by line. Maybe in upcoming session now, I can have the entire piece of code and which I will take you through. Okay, what are we are doing that? But if I randomly show, if I suddenly show you that, let's say 20 line of code, sometime who is very new into coding and all, for that, them maybe it would be difficult, right? So that's why let's now cover all the operation one by one, and then we can get into the more details. So here I have the total employee as let's say 21 employee I have in my employee CSV. That's why it's got a 21 count. Right. So there are other operations as well, aggregation. Maybe we can cover it in next session. Um, s- yeah, we'll cover it. Apart from that aggregation operation, we also have some Windows operation and other advanced topic like UDF and all. So we will cover those things in upcoming session, guys. Any question for me before we conclude today's session? Something not clear to you guys?
As of now, we are good.
Okay. So fine. See, today we cover these things, right? As well, the YAN architecture, right? Yeah. See, uh, basically, when you guys work on Databricks or Synapse, that time you won't see all this underlying architecture and all, because they themselves manage with the help of uh, if you are running your code on Databricks, they have DBFS file system, that Databricks file system, and if you are running on the Synapse, they have Azure Blob Storage file system. But what this HDFS architecture is, guys, this HDFS file system is nothing but the file system which is built on top of your disk storage, right? Whereas in case of Databricks or Synapse, it's a file system built on top of their S3 in case of Databricks and their Azure Blob Storage in case of Synapse. So that's the difference, guys. But underlying, this is a main architecture that you should know that, okay, this is what actually is main thing, and they build a wrapper on top of that. So first idea is this one, YAN and HDFS architecture. So this part, this part, right? You see whatever over here. Why I'm focusing, because I know this part have its own weightage. So this entire part we cover in YAN, right? So whatever you see over here, this entire architecture, resource manager, node manager, all and all. This is what your right, this side, okay? This right side. And HDFS architecture is on your left side, distributed. So when you are uploading any file, right? Forget about the Spark job or anything. When you are uploading any file, then this time HDFS architecture would come in picture. In HDFS, you have, I told you, right? There is a master and worker node. You have the central name node. That name node take the input from the client and store your file in term of data block as a data block across the different worker node that it have, right? And it also do data application. So one partition. So when I'm saying data block, they are nothing but partitions. 120 MB is a default partition size. Let's say you apply a 5 GB of file. So that way, maybe 40 partition it would create everywhere in all these worker nodes. and it also do the data replication and all, so that data should be highly available. So that's completely job of HDFS and name node, right? And they take care of it before your Spark job run, right? This is a job when you upload the file you're in data in cluster, HDFS cluster. And once you upload it, when you run the Spark job, then this side come in picture. Yep. All right, guys, that's what I just wanted to quickly beep through. If no question, maybe we can conclude today's session, and tomorrow maybe we will talk on further transformation action plus window operation and other advanced topic in the Spark, and then we will move on AWS and other topics. Right. So we'll conclude today's session, guys. I hope no further question. I'm stopping recording.
Sure. Thank you
Okay.
so much.
Thank you. Thank you.